In this video, let us continue to solve more problems based on complex numbers. Alright, here we've got a problem which reads like this. It says, write the following complex number in polar form. So we've got a complex number here which is 1 plus 2i divided by 1 minus 3i. The first step that we have to do is write this in the form of a plus ib, which can be written by multiplying both the numerator and the denominator by the conjugate of the denominator, which would be 1 plus 3i. So multiply both the numerator and the denominator by 1 plus 3i, and what you get is you first have to multiply the numerator. So the multiplication of complex numbers is nothing but it's a1 a2 minus b1 b2. So yeah, when you've got two complex numbers, say for example, I'm writing this for those who don't remember the multiplication formulae of the two complex numbers. So when you have two complex numbers, a1 plus ib1, and which has to be multiplied with another complex number, a2 plus ib2, what you have to do is you need to write it as a1 a2 minus b1 b2 plus I times a1 b2 plus a2 b1. So this is the formulae. So applying that here, we get, so a1 a2 is going to be 1 and b1 b2 is going to be 2 times 3, but it's minus of b1 and b2, so it's going to be minus 6 plus I times a1 b2. a1 is 1, b2 is 3, so it's going to be 3 plus a2 b1, so 1 times 2, it's going to be 2, divided by, this is the form a plus b into a minus b, which is a square minus b square, so it's going to be 1 minus 9i square, right? So which is equal to 1 minus 6 is minus 5 plus 3 plus 2 is 5 again, so it'll be plus 5i divided by I square is negative 1, so negative 1 times negative 9 will be positive 9, so positive 9 plus 1 is nothing but 10, right? So it's 10, so it'll be, in the next step what we'll do is we'll just simplify this a little further. So we can take out 5, factor out 5, we'll have minus 1 plus I divided by 10, which will make it 5 goes 2 times in 10, right? So it'll be minus 1 by 2 plus I by 2. So this will be the complex number of the form a plus ib, right? That's the first step that we've done, okay, in order to convert this given complex number into its polar form. But the next step, now that we've found its a plus ib form, the next step is we need to find the modulus and then find the argument and then eventually write it in the polar form. So let's find the modulus. That is, say, if you have to write this, let's say this is equal to z. If you want to write it in its polar form, it will be of this form, r times cos theta plus I sin theta, right? So r is nothing but the mod of z, which is given by square root of a square plus b square. In this case, the a is minus 1 by 2. So minus 1 by 2 whole square. In this case, it is plus 1 by 2. So it will be plus 1 by 2 the whole square. So what we have here is 1 by 4 plus 1 by 4, which is nothing but half. So I just leave those calculations to you. So it'll just be the square root of 1 by 2. Square root of 1 by 2, or you can write it as 1 divided by square root of 2. So that is the r, or modulus of z. So we found one part of the problem now. The next part is to find the argument. You know that to find the argument of a given complex number, we first have to find alpha, which is nothing but tan inverse the mod of the imaginary part of the complex number divided by the real part of the complex number, right? So alpha is given by tan inverse the mod of the imaginary part of the complex number, in this case is 1 by 2, divided by the real part of the complex number is negative of 1 by 2, right? So which is nothing but tan inverse alpha equals tan inverse the mod of half and half gets cancelled, will be minus 1, right? So now tan of what gives you minus 1? So in this case, alpha is equal to tan inverse of mod of negative 1. So we really don't have to consider the negative sign because it's the mod. So alpha equals tan inverse of 1, alpha equals pi by 4, right? So since it's the mod of negative 1, alpha equals, so the negative not considered, and it's just tan inverse of 1, and alpha equals pi by 4. So now to find the argument of the given complex number, we first have to see that the imaginary part of the complex number is greater than 0 and the real part of the complex number is less than 0. In that case, the argument of the complex number z will be given by pi minus alpha, right? So the argument of minus half plus I by 2, which is the complex number in this case, will be equal to pi minus pi by 4, which is equal to 3 pi by 4. So this almost completes the problem. We just have to substitute the given values in this expression here. Z equals, R is given by 1 by square root of 2 times cos of 3 pi by 4 plus I times sine of 3 pi by 4. Theta is nothing but the argument of the given complex number, which is 3 pi by 4. So this given thing is the polar form of 1 plus 2i divided by 1 minus 3i. Alright, so that ends this problem as well as this video. I'll see you in the forthcoming videos with more concepts based on complex numbers.